All right, so let's do our last example and see how we can do with it. So for this last example, we're going to do the limit as n approaches infinity, and we're going to do x plus 2. So this is going to be the n plus 2, right? This is going to be the n plus 2, so let's just go ahead and rewrite it like this. And this will be the n plus 2 squared. And we're going to multiply by the reciprocal of this. And hopefully that makes sense to you guys, because we've done this so many times now, right? So many times in the last couple of videos. Okay, so let's go ahead and start canceling stuff out. So this cancels with this. And yeah, that looks pretty good for me here. And this little guy right here is going to cancel with this right here. So what we're left with now is the limit as n approaches infinity. And again, just like previously, I'm going to go ahead and group the n's together first. And I can find that limit, and that's going to tell me what I really need to know about my x values, right? So all I'm left with now is the x minus 2, which is less than 1 for our limit. And so just like before, I don't really care about the plus 1, the plus 2. If I'm looking at just this particular limit, I know that this value right here, this particular example, I know this particular example right here, that's going to go to 1. And so all I need to then worry about is the fact that x minus 2, that absolute value, must be less than 1, which means that x minus 2 must be less than 1 and greater than negative 1. X must be less than 3, and it must be greater than 1. So again, this is going to be our interval of convergence. We see the center in this particular example is at 2. It's halfway between 1 and 2, and our radius is going to be equal to 1. All right. So just like in the previous examples, we must check our endpoints. So the first thing we're going to do is we're going to plug in what happens when x is equal to 1 back into our function right here. And so when we do x is equal to 1, we're going to go ahead and... All right, so when x is equal to 1, we're going to get negative 1 on the top. And then we're going to get n plus 1 over 2 in the bottom. Well, if n is equal to negative 1, then again, we have an alternating series. So this is going to be an alternating series test. So all I really care about is finding the limit as n approaches infinity of n plus 1 squared. That's going to give me 0. So I know that's good. I also know that my second term is going to be smaller than my first term. So I know by the alternating series test, right, the alternating series test, I know for a fact that this is actually going to converge at 1. So I know that we're going to be good for that particular example. If we look at what happens when x is equal to 3, so we'll bring this little guy up here. When x is equal to 3, we get the summation. And so this will be 1, right? This is going to be 1. And so 1 raised up any power is going to be 1, so I can just kind of leave that alone 1, and then I'm going to get the n plus 1 squared. So if I look at this, I can use the direct comparison test, right, to say that this is very, very similar to the function 1 over n squared. This is the p series. It's perfect. It's right there. So I know that this is going to converge. And so I now can say that this is an example where both of my endpoints actually converge as well. So the interval of convergence for example number 3 is including 1 all the way to 3, including 3. So I hope those are helpful, and there's a lot of examples down in our notes that you can practice, and hopefully this helps you guys out. So thanks, and I'll see you guys in the next video.